Hello everybody, today I'll be showing you my hack and slash sample engine that I built a long time ago. Those of you who may or may not know me, I work for a company called UOK Software and I am leaving that company on good terms, of course. What is happening is that we are switching from a desktop application company to a mobile app company, and I am not a mobile app developer, and I don't have a whole lot of interest in mobile apps at this time currently. So what I'd like to do, instead of wasting all these desktop applications that I built and all these desktop engines that I built in Visual Basic, because I was the only developer, VB developer there, I'm going to go ahead and share with you guys how to build these, how to build game engines, or some of these game engines in Visual Basic. So if you're a mid-level developer and you're looking to understand game engine concepts a little bit more in depth, this is probably going to be the right video series for you. So let's go ahead and get started. What we have here is picture boxes. Right off the bat, I would tell you right now, I don't recommend picture boxes. When I built this is strictly just a quick sample for myself that I built, and I didn't put a whole lot of effort into it initially. It was more or less just for testing. However, it will give you an effective understanding of how to build a simple side scroller and a hack and slash. So let's go ahead and take a look here. What we've done is we have 3 bad guys, and then I have my little invisible block. What I did with this block is I simply just put down a picture box, and then I set the location to this point, and what it did is it automatically maximized my screen to give me the scroll bar, so I can go there and I can set that point there, and then I could position these guys anywhere I wanted them, just for testing purposes, of course. Now my labels, this is my first label, it's my player. The next one is the bad guy 2, bad guy 3. What we're going to see is the player only moves up and down. It creates an optical illusion that you're actually moving when you're really not. The only thing that's actually moving, though, would be your background itself, and the players itself, your enemies themselves. So we'll actually see how that works here in just a second. So when you're building a two-dimensional game slash side scroller, hack and slash, whatever, your player should not be moving. You actually should move your characters and your other objects. So let's go ahead and take a look and see how that works. Normally I would comment my code. I'm very big on commenting my code, but because this is such a simple sample that I made myself, the regions actually do a very good job of acting as comments for us, so there's not really a whole lot of logical explanation that's needed. Alright, so first thing I did is I turned off auto scroll, which if we come back here, this is auto scroll. It would actually show this scroll bar if I did not turn that off, which is bad, because then you could just scroll ahead and see the entire map, or the construction of the entire map if you're a player. So you don't want that. So you got to turn that off. The next thing is that I built a sub called chords, or coordinates. This is simply just displaying the locations of the player and all the bad guys. This simply is just a visual for you for testing purposes, to let you know where everything's at, to ensure that it's working. The next thing is our movement. This is the player's movement. What we have here is when we move, we don't actually move. As I said, we only go up and down, and we give the illusion that we're going left and right. Well, that's exactly what we're doing right here. We're only giving the illusion that we're moving left and right. And who's actually moving? The bad guys. Those are the ones who are actually moving left and right. So when you press your keystroke, these objects are the only thing that moves left and right. Now what it does every time you do that key press as well, or every time it ticks, because these are timers, it simply checks the chords so it can display, its coordinates to you, so you can see the movement actually occur. Now here is the movement for up, and here's the movement for down. This is how you simply move up and down. not very complex. It's actually pretty self-explanatory. You have your X for moving left and right, and you have a Y coordinate for moving up and down. That's simply all we're doing right here, is we're finding out who needs to move. Are we moving the player? Are we moving the bad guys? You know, who's moving? Everybody needs to move. So there we go. So everybody's moving. The next thing is our enemy movement. What's going on here? This is a little bit more complex. What's happening here, believe it or not, what will happen at a certain point, which at our point it's 10:25, is the point where the bad guy will actually automatically start chasing you, the player, and he will try to match your X and Y coordinate. Right here he tries to match your X coordinate, and right here he tries to match your Y coordinate. I know that may not make a little bit of a sense right now, but as soon as I start the program, it will actually make a lot more sense. So just for now, note this logic, take a look at it. It's a fairly simple algebraic equation, and it's just a comparison, you know. So just take a look at it briefly. The last thing is the keystroke. I want to talk a little bit about keystroke and the logic real quick before I show you the actual program. Now, computer logic says on the key down event, it says when you press this key down, I'm going to perform this action, which it turns on. In this case, in the D case, in the case of the D key, it's simply turning on move right, enable true, and it's turning off move left. Now you want to turn off the move left just in case that somebody had actually enable that, so it just kind of counter react the user essentially, as well as logic as well. So what happens here though is when you press a key, it's going to run this line of code or this section of code. Now when you lift up on the key, you never told it what to do when you lifted up on the key, so it's going to continuously run this line of code until you tell it, you know, when this event occurs, you know, stop running, which is why we have the key up event. So logic says, or the computer says, you never told me what to press, you know, when the key is up, so I'm going to keep running. But in our case, we are telling it what to do when that event occurs, so we need to tell it to stop. That's just a basic mechanical logical understanding. Essentially, you have to hold the computer's hand and tell it what to do. You just simply have to say, hey, I want you to do this when this event occurs, and then when, you know, this event is no longer needed, in this case the key up, go ahead and cancel that event essentially. Alright, so that's what's happening there with our movement. If you're not familiar with key movements and interacting, you might want to familiarize yourself with that. It's a pretty basic concept. This is generally how you move a player around or an object around on a form. Alright, so let's go ahead and go back to the designer and let's go ahead and start debugging. Alright, so as I was saying, we have our point where our player is starting, which is at 300 by 600, and then we have our bad guys' points where they are starting. Now, I'm going to simply just move up and down, and what you will see is the y-axis for everything changing and the x-axis does not. So I'm going to press W and S because those are the two keys that go up and down, and as you can see, as predicted, only our y-axis value is changing. Now, I'm going to go forward and backward just a little bit, and you will see that only the x-axis will change. And those keys are A and D, which these key sequence is very common for most games. If you've ever played any game, these are probably the keys that you use. So I'm moving left, moving right now. Since I went forward a little bit too much, as you can see, bad guy 1 is already coming after me. He's trying to match my x and my y coordinates consistently, and he will do that until he reaches a certain point. In fact, I'll sit here and I'll let him reach that point. Now he's reached that certain point, he's X amount of space away from me, and now he's no longer going to chase me. Now what we can do on my end, because this is poor collision detection, I can walk right through him. However, he will continue to chase me. The good thing is, though, is that I can outrun him. So I will go ahead and move forward. You can see that he's slowly drifting away. What's occurring there, though, is simply that I move slightly faster than him, so I can outrun him. What you would see most commonly in a lot of games, like, see, we can match each other's speed going up and down, but when I move left and right, he's slower. Now, you would see this concept a lot with, particularly I've seen this concept a lot with a game called Ultima Online. It was the very first MMORPG ever created. I believe the platform was Windows 98 / Windows XP, so extremely old. But nevertheless, this concept's been around that long, and that's the point. This is how we do side scrollers. This is how we do hack and slashes in 2D. The concept's been around that long, and still widely used to this day. You don't have to use necessarily a bad guy for this. You can use other players. You can use pets for your player. You can do a lot of things with this. Alright, so let's move on. Let's see what happens when the other bad guy reaches that certain point, or that magical number, when he's going to start chasing me. Alright, there he is. As you see, they're both mashed up. I'm going to move, and there we go. Now, logically, what you would want to do in a real-life environment, first things first, you would want to build a collision detection system with basic physics, of course, where I would push him away, or he would push me. If we're in, if he's running toward me and we're so close to each other, instead of running through each other, I need to push somebody. Either they need to go that way, or they need to go that way, or that way, or whatever. They need to go in some kind of direction. So that's the first thing you would probably want to put in your engine for a more complex engine. The next thing, you would definitely not want to use picture boxes. You would want a rotating background using the paint option or the paint event. So every time you move, you would have to redraw the screen. Or you could have one giant image which would move left and right as well, just like the enemies are. Or you would have tiles. Most commonly, you would probably build using tiles. Most games that I've seen use the tile concept. The tile concept's been around probably since Windows 95 or longer. I mean, I would say it's probably safe to be around maybe as low as maybe Windows 3.1 or Windows 3.11. Or maybe Windows NT, I don't know. It's been around forever. Ever since we went to a UI-based game concept and we stepped away from console-based or command line-based, I think we're using, these methods for, object-oriented or even just command line-based construction of games. All right, so feel free to subscribe. Post your games if you find this engine useful or this sample useful. Post it. I'd love to see it. Give me some feedback. Let me know what you like, what you don't like. If you have any recommendations as well, feel free to post them. This engine is not perfect. It's always open to interpretation. There's always bigger and better methods out there, and please feel free to share those with us, because as all of us as developers, I'm sure we're all looking to learn better methods, and the only way that we can learn better methods is through sharing those methods with each other. Alright, so thank you, and please subscribe.